Dear students, welcome to this lesson on language of chemistry. Today, you're going to learn how to count the number of atoms in a formula. You will also learn about chemical reactions. At the end of this lesson, you will be able to count the number of atoms in formulae of compounds. Identify reactants and products in chemical reactions. Write word equations to represent chemical reactions. Recognize that chemical reactions involve rearrangement of atoms. In the previous lesson, you learned how to write down the formulae of compounds. For example, sodium chloride has formula NaCl. The formula of aluminium oxide is Al2O3. Iron 3 sulfate has formula Fe2SO4 thrice, and ammonium nitrate has formula NH4NO3. Today, you will learn how to count the number of atoms in a formula. Let's have a look at the formula of sodium chloride NaCl. Recall, when there is no subscript for a particular element in a formula, it means that there is one atom of that element. Thus, in NaCl, there is one atom of sodium and one atom of chlorine. Let's have a look at another example, Al2O3, which is aluminium oxide. You will notice that there is a coefficient 3 in front of Al2O3. This means that there are 3 units of Al2O3 here. We will first count the number of atoms in 1 unit of Al2O3. As you can see, the subscript 2 shows that there are 2 atoms of Al, and the subscript 3 shows that there are 3 atoms of oxygen. Now, if you have 3 units of Al2O3, the total number of aluminium atoms will be 3 times 2. Remember, 3 is the number of aluminium oxide units and 2 is the number of aluminium atoms in 1 unit of Al2O3. Similarly, the total number of oxygen atoms would be 3 times 3, which is 9. Thus, in 3 units of Al2O3, there are 6 aluminium atoms and 9 oxygen atoms. Let's consider a third example, NH4NO3, ammonium nitrate, which is made up of 2 radicals, the ammonium radical and the nitrate radical. As you can see, there is 1 nitrogen atom in NH4 and 1 nitrogen atom in NO3. Thus, there are 2 nitrogen atoms in NH4NO3. Also, there are 4 hydrogen atoms in the formula, and there are 3 oxygen atoms in this formula. Another example that we are going to have a look at is iron 3 sulfate, which has formula Fe2SO4 thrice. The coefficient 3 in front of the formula shows that there are 3 units of Fe2SO4 thrice. Let's first count the number of atoms of each element in 1 unit of Fe2SO4 thrice. As you can see, there are 2 atoms of Fe. There are 3 SO4 radicals. In 1 SO4 radical, there are 1 sulfur atom and 4 oxygen atoms. Thus, the total number of sulfur atoms in Fe2SO4 thrice is 1 times 3, which is 3. And the total number of oxygen atoms is 4 times 3, that is 12. Now, if we have 3 units of Fe2SO4 thrice, the total number of Fe atoms is 3 times 2, which is 6. The total number of S atoms is 3 times 1 times 3, which is 9. And the total number of oxygen atoms is 3 times 4 times 3, which is 36. In grade 8, you learned about chemical reactions. You will recall that a chemical reaction is a process during which new substances are formed. You also learned that the starting substances in a chemical reaction are called the reactants, and the new substances formed are called the products. In short, in a chemical reaction, reactants are converted into products. Let us recall how a chemical reaction is represented in the language of chemistry. A chemical reaction can be represented by a word equation. In a word equation, the reactants and the products are separated by an arrow. Remember, the reactants are placed on the left side of the arrow and the products are placed on the right side of the arrow. Note, the head of the arrow points towards the product side of the equation. Let us see how we write a word equation. For example, magnesium reacts with oxygen to form magnesium oxide. Magnesium and oxygen are the starting substances and therefore they are the reactants. Thus, they are placed on the left side of the arrow. Magnesium oxide is the product and is placed on the right side of the arrow. The word equation for the reaction is magnesium plus oxygen gives magnesium oxide. Another example of a chemical reaction is the reaction between iron and sulfur to form iron 2 sulfide. Iron and sulfur are the starting substances. They are the reactants and are placed on the left side of the arrow. Iron 2 sulfide is the new substance formed, therefore it is the product and is placed on the right side of the arrow. Thus, the word equation for the reaction is iron plus sulfur gives iron 2 sulfide. A third example of a chemical reaction is zinc oxide is formed when zinc reacts with oxygen. Here, zinc oxide is formed, therefore zinc oxide is the product. The starting substances are zinc and oxygen, therefore zinc and oxygen are the reactants in this reaction. Hence, the word equation for the reaction is zinc plus oxygen gives zinc oxide. Let's have a look at another example. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. Magnesium and hydrochloric acid are the reactants in this reaction, whereas magnesium chloride and hydrogen are the products. Hence, the word equation for this reaction is magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. You have now recalled that a chemical reaction is a process during which reactants combine to form products. Let us now see what happens to the atoms of the reactants in a chemical reaction as they combine to form products. We will refer to the reaction between carbon and oxygen to form carbon dioxide. The word equation for this reaction is carbon plus oxygen gives carbon dioxide. As you can see, an atom of carbon is represented by a sphere labeled C. Oxygen is a diatomic element and has formula O2. Therefore, it is represented by two spheres labeled O joined together. Carbon dioxide has formula CO2 and is represented by a carbon atom attached to two oxygen atoms. You will notice that there is one carbon atom on the reactant side and one carbon atom on the product side. Similarly, there are two oxygen atoms on the reactant side and two oxygen atoms on the product side. Thus, the carbon atom and the oxygen atoms are present on both sides of the arrow. This means that there has been a rearrangement of the atoms of carbon and oxygen to form the new substance carbon dioxide. Let us recall what we learned about a chemical reaction. In a chemical reaction, the atoms of the reactants are rearranged to form products. Every atom present at the start of the reaction is present at the end of the reaction. Thus, in a chemical reaction, the total mass of products is equal to the total mass of reactants. Let's summarize what you learned in today's lesson. A chemical reaction is a process during which new substances are formed. The starting substances in a chemical reaction are called the reactants, and the new substances formed are called the products. You also learned that a chemical reaction can be represented by a word equation. In a word equation, the reactants are placed on the left side of the arrow and the products are placed on the right side of the arrow. You also learned that in a chemical reaction, the atoms of the reactants are rearranged to form the products, and every atom present at the start of the reaction is present at the end of the reaction. You can practice counting number of atoms in formulae from your MIE Grade 9 Science textbook on page 399 and page 401. You can also practice writing word equations on page 403. This lesson was presented by Ms. Dukia, chemistry educator. Thank you for your attention.